Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about the free radical addition of hydrogen bromide to an alkane. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So the free radical addition of hydrogen bromide to an alkane is one of the reactions of alkene. Now let's have a look at this general equation. So if we have an alkene, the general form of an alkene, then we add hydrogen bromide to it. Normally the product that we get is what? The bromine over here is being attached to what? The more substituted carbon. So assuming in this case this is our more substituted carbon, let me use asterisk over here. If this is the case, so it means our bromine over here, upon reacting with what? This alkane, the bromine will be attached to the more substituted carbon, which I'm using as this. So we are going to have this, then with the bromine attached to it, then the hydrogen over here will be attached to the less substituted carbon, and then we have our product, this as our product. So this reaction is what we call the hydrohalogenation. The hydrohalogenation of what? Of an alkane, and it goes via what? The Markovnikov's addition. Markovnikov's addition. Okay, but now what if we want the bromine? Okay, if we want the bromine, okay, on the less substituted carbon, okay, that is in this example, if we want the bromine to be what? On this carbon rather than this carbon, what do we do? This is where the free radical addition of what? Hydrogen bromide comes into place. So for this reaction, if you want it to go via the anti-Markovnikov's addition, all we need to do is to add what? A peroxide, okay, to this reaction. Once we add a peroxide to this reaction, it does not go via the Markovnikov's addition again, it goes via the anti-Markovnikov's addition. That is, if we still have our alkene, and then we add what? Hydrogen bromide in the presence of what? A peroxide. Okay, once we add a peroxide to it, we get what? The anti-Markovnikov's product. That is, we add the hydrogen to the more substituted carbon, and then we add the bromine to the less substituted carbon. So let's have a look at how this reaction goes. So like I said, the general alkene formula is this, and then we are adding what? Hydrogen bromide in the presence of what? A peroxide, which we are saying is this. So if this with the asterisk, this carbon is our more substituted carbon, it means if we react this, we are going to get the hydrogen being attached to the more substituted carbon, and then the bromine being attached to the what? To the less substituted carbon. So let's look at the mechanism for this reaction. So the first step that we call the initiation stage, or the initiation step, is the what? Is the formation of what? The radical, okay, or the alkoxy radical. What do we mean by this? So the peroxide that we have over here, okay, would decay or would dissociate in the presence of heat to produce alkoxy radicals. Okay, so it means this peroxide over here will undergo what? Homolytic cleavage. Will undergo what? Homolytic cleavage to produce what? Alkoxy radicals. So it will produce this, then with one electron from the bond over here, then another one, okay, with one electron. Okay, so this is what we get, and so this is what we call the alkoxyl radical. Now once the alkoxy radical is produced, one of these radicals will now react with what? Hydrogen bromide. Okay, so during the reaction, okay, this we have one electron here, then we have two electrons over here. So one of the electrons will react with this, and then breaking the other electron onto the bromine over here. So from here we get what? The O now forms a bond with the hydrogen, then we have what? The bromine radical being produced in solution. Now once we have the bromine radical being produced in solution, it will now go and then attack the alkene that we have. So we have our alkene here, then plus the bromine radical. Okay, mind you, we are saying this carbon is the most substituted carbon, and because we have what, a peroxide in this reaction, the bromine will what, will attack. This will happen, one of the electrons from the double bond, okay, will react with the one electron over here of the radical, will react to form a bond. Now that bond will be situated on the what, on the less substituted carbon, which is this one that we have over here. So we have this single bond, then we have this, and then Br. Okay, so if this happens, it means the second electron from this bond will now be placed on the most substituted carbon. So we have the most substituted carbon, which is this carbon here, becoming a radical. Okay, once we have this radical, okay, because this carbon is the most substituted carbon and the radical is on it, it is now very, very stable, and hence the reaction can continue. So another hydrogen bromide will now come. So from here, this radical will also react with the HBr. Mind you, I'm using half arrow, which means what, one electron from here, one electron from here, to form a bond. So this one also breaks onto this. So once the HBr now reacts with this radical, we now have this with the hydrogen attached to our most substituted carbon, and then we have the bromine attached to the less substituted carbon, and then we have the bromine radical over here, this in solution, plus this radical in solution. Now this is now our product. This we have over here is our product, but we can see that we have another bromine radical in solution. So because we still have another bromine radical in solution, this reaction is described as what, as a chain reaction. That is, even upon getting the product, if we still have the bromine radical will still be produced. So in the presence of what, excess alkene, this bromine radical will now attack another alkene molecule to produce the product, and then yielding another bromine radical, and then it goes on and on and on until we get what, more product, or until we no longer have any alkene for the reaction to further continue. All right, so let's have a look at an example to actually appreciate what we are doing. So the first example we want to look at is the free radical addition of what, HBr to what, to propene, in the presence of what, a peroxide. Okay, so let's have a look at that. So if we are having a propene is of the form, have this is propene, H, then we have hydrogen, then we have CH3. Propene means it has 3 carbons, so we have 1, 2, 3, and then we have the double bond in between them. So this is propene, and then we are adding what, HBr, hydrogen bromide, to it in the presence of what, a peroxide. So straightforward, we know this reaction will go via what, the anti-Markovnikov's addition, because of the presence of the peroxide. The bromine radical will attack the less substituted carbon, and then we have our product over there. So straight from here we can see that we are going to get this as our product, CH3. Then the hydrogen will come to, this is the most substituted carbon, so the hydrogen will come here. Then we have this, and then our bromine will now be attached to the less substituted carbon, plus another bromine radical in solution. Okay, so let's write the mechanism for this. So the mechanism is straight ahead. Before even the reaction occurs, the peroxide has to what, dissociate in the presence of what, the presence of heat. So this is what goes on. We have heat over here, so this will undergo homolytic cleavage to produce what, 2 alkoxy radicals, which looks like this. So this is what we are calling the alkoxyl radical. Now once the alkoxy radicals are being produced, we have the alkoxy radicals, okay, one of them reacting with what, hydrogen bromide. Okay, so one of these will form a bond with the hydrogen using one electron, breaking the other electron onto the bromine. So we have this produced, okay, then plus the bromine radical. Okay, so this is the electron that is obtained from the breakage or the cleavage of this bond. Now once we have this radical bromine radical will now come and attack the propene for us to get our product. So let me do that on a new page. So we have our propene CH3 doubly bonded to another CH, then H. So we have our what? Br radical. So this bond will come, then this will also attack to form our what? Our radical intermediate. Now because this carbon is the less substituted carbon, it means the bromine will be attached to this carbon, so the other electron that is within this bond will be what? Will not be attracted to the most substituted carbon. So we are going to have this, then we have our CH3, then we have the radical on the most substituted carbon over here, then we have single bond, then we have the H over here, hydrogen here, then we have our bromine over here. Okay, so once we have this, we can see that this radical is the carbon over here is attached to two other carbons, so it is what? More stable than if the radical were to be here, which would just be attached to what? One carbon. So this radical is more stable than what? If we have the radical over here. So from here, another HBr in solution will now react with this radical. So one electron from here will now react with this electron, breaking the other electron onto the bromine, and then we now get our product, which is in the form CH3 carbon hydrogen, then we have the hydrogen over here, then we have CH with a bromine plus another bromine what? Radical in solution. Okay, so this is the product that we get, and then this bromine radical, if there are excess what? Alkene molecule in the solution, this bromine radical will go and react with the propene again to produce this product again, and then the reaction continues. Okay, but this is our product, and then it is what? An anti-Markovnikov's addition. Anti-Markovnikov's addition. That is what? We are adding the bromine to the less substituted carbon. Okay, also before we continue, we need to note something. This reaction, let me use another color to demonstrate that. This reaction is only possible if we add what? An alkene. If we add an alkene to what? Hydrogen bromide in the presence of what? A peroxide, to get what? Our anti-Markovnikov's product. Which means if we add another hydrogen halide such as what? HCl or hydrogen iodide, this reaction does not occur, or we don't have the anti-Markovnikov's addition. Why is it so? This is because what? The reaction of what? HCl and then hydrogen iodide do not undergo the reaction, because what? The reaction between HCl and then what? Hydrogen iodide with alkene is an endothermic reaction. So because it is an endothermic reaction, the reaction does not have the right what? Reactivity for the radical chain reaction to occur. So to note is the fact that the addition of what? Alkene with HBr, okay, because we have a peroxide over here, the peroxide brings about a new term that we call the peroxide effect. The peroxide effect. This is E. Now the peroxide effect is simply the change in what? Regioselectivity of addition of HBr to an alkene in the presence of a peroxide. So we can see that normally if we don't add peroxide over here to this reaction will go via the Markovnikov's addition, where the hydrogen bromide, the bromine will be added to the more substituted carbon. But because we have a peroxide over here, and due to the peroxide effect, the hydrogen bromide, the bromine is being added to what? The less substituted carbon instead of the more substituted carbon in hydrohalogenation. So let's continue with another example. So we have this alkene as the starting material, CH3. Then we have double bond C, CH3, CH3, plus what? HBr, in the presence of what? A peroxide. So we are being asked to write the product and then the mechanism as well. So straight ahead, because we have the peroxide over here, we know this reaction will occur via the anti-Markovnikov's addition, which means the bromine will be attached to the what? To the less substituted carbon. If we look at this starting material, we know that this carbon, okay, has only one alkyl group, and this second carbon has two alkyl groups. So therefore this carbon is the what? The less substituted carbon. So the bromine will be attached to this carbon, so we can write our product without even thinking. So we have our bromine here, then we have CH3 at the top, CH3 here, then we have our hydrogen here, plus another bromine radical in solution. Okay, so how can we convince someone that this is actually what happens? So let's write the mechanism for this. So in the mechanism, first step, we know that what? The peroxide will dissociate, okay, homolytically to produce what? Alkoxyl radicals. So we have this, okay, don't forget the two lone pairs that are on the oxygen. So once we have the radical, this radical, okay, will now react with what? Hydrogen bromide. And then if this happens, one of the electrons over here will react with this electron, breaking the other electron onto the bromine. So we have this, which is technically an alcohol, plus what? Br radical. Okay, so this radical now goes to initiate the reaction. So we have our alkene with CH3 doubly bonded to C, CH3, CH3. Then we have what? The bromine. Let me write it somewhere here, small. Radical. I will just ignore the three lone pair over here. So this one of the electrons over here will now attack this. Okay, so because this is the less substituted carbon, it means the bromine will go here. So the other electron will be what? Will now come onto this carbon. So we have what? Our CH. Then we have the bromine. Let me put it here. Then the CH3. Then we have this. Then the radical will be on this carbon. Then we have CH3, CH3. Okay, so we can see that we form the radical on the most substituted or the more substituted carbon over here. So from here, another what? HBr will now come and attack, and then we have this occurrence. So from here, let me use another color to write the product so we can differentiate. So from here, we can see that our product will be what? We have the bromine over here attached to the carbon with what? Hydrogen, then CH3, then attached to what? The new hydrogen will now form a bond at the top over here, which is this one. Then we have our CH3, then our CH3. So this is the product plus what? Br radical in solution. And then this Br radical will then go back and then react with the alkene again to form the product, and then it continues. Like I said, this reaction is a chain reaction. Now let's look at one more example and then we end this tutorial. So in this one, we are going to use a cyclic alkene. So this is our alkene, and we are adding what? HBr in the presence of a peroxide. This one we have been given a distinct peroxide, so we have this as our peroxide, CH3. Okay, and then we are being told to find what? The product of this reaction. So the moment we see what? An alkane, we see HBr, and we can see what? The peroxide, example of a peroxide given, we know straightforward this reaction will go via the anti-Markovnikov's addition. So mechanism. First of all, we know the peroxide over here, CH3, C double bond O, 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 C double bond O, CH3, will undergo what? Homolytic cleavage in the presence of what? Heat. Don't forget this, in the presence of heat, to form the alkoxy radical. So in this case, we are going to have this CH3. Mind you, this will undergo the homolytic cleavage like this, so the electrons have been shared. So we have this O, then O with what? The radical over here. So we have two of this. Alright, so once we have this, oxygen always has two lone pairs. So once we have this, the CH3, the radical, the alkoxy radical over here, okay, will now react with what? With the hydrogen bromide that we have over here. So we have the HBr. So this happens, okay, breaking this one of the electrons onto the bromine. So we have CH3, C double bond O, then we have O, then H, and plus the Br minus, sorry, the bromine radical in solution. So the bromine radical from here will now attack the alkene. So we have our alkene over here plus the Br radical. Okay, let me use this. So this is our radical. Okay, now if we look at this, the double bond over here is between this carbon and this carbon, and we can see that this carbon here is attached to 1, 2, and 3 other carbons, and this one over here is attached to just 1 and 2. So this is our most substituted carbon, which means when this double bond breaks, okay, and one of the electrons react with this radical, the bromine will be attached to the less substituted one over here, and then the second radical, sorry, the second electron over here will be what? Brought to this carbon, which is the most substituted one. So we have this. Okay, sorry for how I'm showing the arrow poorly over here. So we have this, and then the radical will be here, and then we have the bromine what attached to the less substituted carbon. So from here, another what? HBr molecule will come, and then will also react using one electron to what? To give us our product. So our product will now be what? This, okay, with the hydrogen over here, then plus the Br radical in solution, which will then go and react with what? The starting material again to form another product for us. So thank you so much for watching. This is how we go around writing the mechanism for what? The free radical addition of what? Hydrogen bromide to an alkane in the presence of what? A peroxide, and this reaction in terms of what? Regiochemistry goes via what? The anti-Markovnikov's addition. So thank you so much for watching once again, and I'll see you in the next video. Bye bye.